All right, moving on into the next session, we're going to welcome Raymond and Elena Lian from Intel Capital, and we're going to talk about semiconductors and the state of the intersect of AI with hardware. So please come to the stage, and we'll move right into the next panel. Thanks.
Good morning, everyone.
Good morning.
So the title of our talk is a bit of a mouthful. Cutting through the fanciness of the title, basically we're going to talk about CVC investment, semiconductor, and AI, or kind of a general topic around those areas. My name is Raymond Chick, a co-founder of a fabless semiconductor startup called Untethered AI. We do AI inference chips. Our second generation product is about ready to get out of the door. A bit of a propaganda here. My other hat is a volunteer with a accelerator, Toronto-based, called Venture Lab. I'm a mentor there. So I'm here basically wearing my Venture Lab hat, mostly. So, Elena, can you tell us about a bit yourself and Intel Capital?
Raymond, such a pleasure. By the way, Untethered AI is a portfolio company of Intel Capital, so a pleasure to be sitting here with Raymond here.
Intel seeded our company 6 years ago.
Yeah. Elena Lian, Investment Director at Intel Capital. Intel Capital, we've been investing as a corporate VC on Intel's balance sheet since 1991. We've been here for quite a while. We invest about, on average, $400 million a year, leading 80% of our deals. We offer term sheet with seats on boards, and it's been quite a ride at the innovation forefront. Very much a pleasure. Today, our topic is mostly on the hardware and AI intersection. So looking forward to this conversation with Raymond.
Right. So apart from Intel Capital seeding my company, Elena also happens to be University of Toronto alumni. We are both from University of Toronto. I'm much older than her, so we didn't never intersect in our past life at U of Toronto. But it gives me a great pleasure to be able to sit with Elena with that kind of background, alumnus, investing in alumnus. So let's move on to our core of the discussion and start by asking Elena, as an experienced deep tech investor and CVC representing one of the most marquee Silicon Valley shop here, what are your high-level thoughts on the rise of the AI from a hardware and chips and semiconductor perspective?
Raymond, arguably, we're at a transformational age. It's a very interesting time. I always want to say, I feel like I'm in the middle of a sandstorm where my eyes can't quite open. So much is happening in the last year and a half, 2 years. But in general, the rise of AI, if I think about it from different elements, the models are growing. Arguably, model size are growing 5 to 10x, 2 to 5x, maybe more conservatively. There's a research showing it's doubling the size every 3 months for the past decade. It's at this amazing rate. And at the same time, the hardware performance is increasing 5 to 10x. While people are putting in the capital expenditure, we're seeing a 10x growth in terms of the investment in the space. And overall, if you multiply everything together, arguably, we're looking at 1,000x of this AI growth a year. And it's really exciting. A lot of the end-using application we can't even imagine yet. And we're at this beginning of this possibility, startup possibility. So the rise of AI is very exciting, yet a little bit hard to see through clearly. But in general, in the hardware space, what we're seeing is that there's definitely an innovative disruption happening from the players, from silicon provider, from the startups, from the hyperscalers, right? If we're looking at it, NVIDIA's leading the market share in the hardware side, definitely. A lot of admiration for their full stack solution, the software solution. AMD is coming up with more HBM, high bandwidth memory, and then more flops. Intel have the Gaudi 3 going. And then we have all the, Microsoft have Maya, Google have the TPU, and right, and just from the startup landscape, there's untethered second generation chip coming out.
Many other startups.
Yeah,
like
Samba Nova, there's Grok who's launched their LPU, claiming very fast sort of the token per second. Right. Just the landscape is humongous, arguably almost crowded.
And also when you talk about my other competitors in the space, in my where I'm from, Toronto, there's another example, Tenstoren. Startup. They are about a couple of years older than us, but they are one of the players that are trying to come into that space.
There's a D-Matrix, there's a number of edge AI, SEMA.ai, the Axelera brain chip, Neuroblade.
This whole slew of startups in my space, basically, doing AI chips.
I'm curious for Raymond, from an entrepreneur, experienced co-founder, you have been at forefront of the startup. What do you see as a resurgence of the hardware semiconductor development in the space?
Right, that's an interesting thought that I've been thinking over the past few years in terms of the sort of, we just talked about the rise of AI, and I'm more thinking about the rise of semiconductor in the sense that, well, we all know semiconductor has been around for a long time, many decades. Starting from a first transistor in the 1947, gone through 7 decades. I've been in that business for designing chips for the past 30 years. I remember when I first graduated in the early 90s, bringing home, talk to my mom and dad, oh, I'm doing ICs, I'm doing electronics, and oh, now you can fix my TV? So that's the sentiment of like people, general public do not know much about semiconductor, chips, and whatnot. But over the past 5 years or so, I'm noticing average Joe, my uncle, talks about TSMC. He talks about 5 nanometer, 7 nanometer, 3 nanometer technologies. Those are my lingos. This is my space. And now it's becoming ubiquitous. It's becoming more general. People have a lot more idea about semiconductors, and people even talking about EUV device, EUV lithography, right? So these are pretty deep into our business. So that's kind of one main thought that I have about semiconductor resurging or servicing as a very common concept, right? And the other thoughts I have about semiconductor and AI is that you talked about there's a lot of, you talked about the AMD and GPUs and NVIDIA and all kinds of new chips that is designed to run AI workloads. Thinking back maybe about 10 years ago, the way I see it is the advent of AI, why it's so explosive in the past few years, is because largely of semiconductor and compute chips. People starting to realize GPUs are very suitable for running AI workloads. It's highly parallelized neural networks, many nodes, much more efficient than CPU. So that's why the move to GPU. And as AI's top-level applications developed over the past few years very rapidly, chip companies like ourselves are starting to use AI design tools to design chips. So semiconductor enabled the recent AI development very rapidly. And in turn, because of the AI tools that are developed at application level, it also helps the development of chip design in a more rapid pace. And so that's kind of my main thoughts around semiconductor and AI. And the last thought I have about supply chain in these AI semiconductor business is we are, as you all know, we are we've been going through a sort of a globalization of a supply chain, manufacturing in Taiwan, Korea, and a lot of front-end R&D and front-end works done in North America, Europe. But the recent trend has been, I'm going to be a little bit controversial here, deglobalization, separation of supply chain. And in fact, Tether AI has gone through a little bit of that to sort of manage our supply chain in such a way that we avoid partnering with a unfriendly geographical nation. It's kind of, I'll leave it at that. And so, well, let me sort of bounce back a question to Elena. And in the midst of all that, as a CVC, how are CVC and yourself and Intel Capital adapting your investment thesis in order to find good deals within the AI semiconductor space? And how would you advise entrepreneurs to position themselves to be able to attract CVC investments?
Absolutely. Before I dive into a couple of trends and how we look at the market, one thing to sort of circle what you were saying, the hardware semiconductor, we're seeing it as a bottleneck for a lot of, especially on the inference side, running a lot of AI workload. So we'll start maybe from there. Just from that, a lot of startups, there's dozens of startups are really innovating, looking at from the inference perspective, which is running AI workload, now the training, there's data that GPT-4 costs $100 million to train. It's just very expensive to tackle. On the inference side, arguably, it's actually the larger size of workload in the deployment cycle. And then from that perspective, there's huge bottleneck because the current GPU structure, there's a limited memory bandwidth. There's a processor to memory connectivity limitation. So we're seeing the startups are actually jumping in here. A lot of startups are doubling down on inferencing side of things. That's one of the trends that we're highlighting on the investment side. And we're seeing D-Matrix, we're seeing Untethered, we're seeing just Grok. A number of startups are really looking at tackling the inference side of things. And also, it's a trend of surgeons where the developers they're looking at use or tweaking training the model already trained by open source, by let's say GPT-4 or by Llama 2, the Meta's open platform. So they're using an existing model and they're looking at deploying it. So that's once again adding the urgency where people are doubling down on inference. So that's one of the trends we're seeing.
Yeah, for sure. Inference is definitely something that at least Untethered AI is going after. And so people have been talking about training for a long time, big models, but inference is the deployment, as you say, and also requires a slightly different set of hardware requirements.
So data I was seeing is the cost is $4 million per day, 50 million user, averaging of 400 words. That's the sort of inference cost. So the cost right now is very high. We need to increase the bandwidth, lower the cost. That's a lot of startup opportunity we're seeing.
Right. In terms of cost, if I can add to that, it also embeds another very important factor. It's energy. So energy is your cost, really, when you run these machines in high power, like a GPU H100 Grasshopper card is like a few hundred watts there, right? So energy is becoming a very topical thing that all startups are trying to tackle, including ourselves here.
Another trend I like to highlight is right now we're seeing transformer is dominating the current architecture. Yeah. Transformers underlying the Llama 2, the GPT-4, and all the current models. However, as the number of context lengths, word lengths grow, the grow linearly, the computational growth is actually exponentially. It doesn't grow just linearly to your point of all the cost and power efficiency and everything and the computational efficiency. So we're seeing in response to that, there's a number of newer architecture. They're trying to be the alternative of transformer. For instance, the state space model or the liquid neural work, they're looking at computational efficiency and how to drive that at a cost-efficient way to scale the AI model. That's the second trend from the investment area we're definitely diving deep into.
Right. This is the energy saving and efficiency is really a problem for the whole stack. I'm sitting in the bottom, kind of in the hardware, but there's a ton of activities up there in the application level. What new models? Every month there are new papers published by Google and other companies. Last month, you read a paper this month, and then you have a different idea of how you re-architect slightly your hardware to fit new ideas that are coming out in terms of models.
Raymond, a question to you is that as a startup entrepreneur, how do you differentiate your company? There's definitely all sort of pressure from financial capital requirement, from the change of regulatory environment, from the continuous innovation to the supply chain management, but how do you differentiate?
Well, I guess from a Untethered AI's perspective, as an example, our major differentiator is very high energy efficiency. And you talked about memory bandwidth and whatnot. Our main approach, main differentiator is what we call at-memory computing versus the standard von Neumann computing where you have a CPU, you have a memory, and it turns out that a lot of AI workloads require a lot of shuffling data between those two entities, and 90% of the energy are burned in shuffling the data back and forth. And a lot of startups, including ourselves, are trying to solve that problem. And our at-memory architecture basically fuse or merge computing elements with memory very, very close together. Instead of running even on chip millimeter wire links, we're running micrometer wire links to reduce the energy required to ship data across wires from chip to chip and whatnot. So that's one of our major differentiator. And from a startup sort of product creation perspective, we started by realizing that our core competence is in architecture, microarchitecture side. So we focused our effort into designing that, building a team, a minimal team around that as a startup, but leveraging my past experience and past relationship with supply chain vendors to help us finish a big and complicated chip, so outsourcing and whatnot. So really, this is how we feel that one of the biggest differentiator is our memory architecture. And I also like to sort of touch on the fact that in terms of getting investment, how do we approach getting investment? Back in early days, it was 6-7 years ago. Especially in Canada, it's very hard to get funding to semiconductor hardware startups. So we went straight down to the valley, and luckily we stumbled upon the Intel Capital who believed in our story, which was just on paper, right? And so we don't have a lot of time left, so we're at the 2-minute mark. So let's move on to some closing remarks by me. Sort of asking Elaine, what do you see in terms of trends and perspective in terms of capital investments coming up in the next?
Yeah, just in summary, in conclusion, right? There's definitely a lot of opportunity here in the AI forefront, but at the same time, it's not without challenge. And the winning for startup to be successful is balancing that continued innovation that Raymond spoke of, that adapting to the regulatory environment change, balancing that financial discipline, sort of cash is king now, extend the runway, and in general go to market and really how do we scale out? Those are a lot of considerations, but great opportunity ahead. Raymond, I'm curious if you summarize the thought for hardware and AI.
Yeah, so we've talked a lot about, in the past 20 minutes, about things. I actually do like to close by bringing a couple key points that I'd like to convey. One is I talked about semiconductor helping AI development, and in turn, AI is also helping chip design. So it's kind of, they feed to each other. It's a positive feedback cycle. So I'm excited about that thing, because I design chips to advance AI, and then I use AI to help to design my chips. That's one point. The other point is I like to bring about the point of, think about what's life after GPU. Now GPU is the king. Everybody goes to GPU to run the AI workload, but there's, as we talked about, a slew of other startups that is creating chips and with architecture that is sort of a next generation, what's beyond GPU, because GPU was not really, at the very beginning, not designed specifically for AI workload. It's just really suitable for AI workloads, but now people are thinking about, if we start from what AI workload needs, what the architecture would look like. So I'll leave you with that thought, and thank you very much for your attention, and thank you, Elaine,
Thank you, Raymond.
to join my discussion here. Thank you very much.